Hey guys, we are on Unit 6. This is day 1, and we're going to start talking about quadrilaterals, which are four-sided figures. In the warm-up, it says that the coordinates of triangle ABC are 2, 2, B, who's at 4, 0, C is at 4, 2, and find the coordinates of the vertices after the composition with a reflection over the y-axis. Remember that the open circle here means following. And also remember that in a composition, it's always the second transformation first. All right, so we're going to do this one first. So the reflection over the y-axis is following the reflection over y equals x. Okay. All right, so remember that reflection over y equals x, we're going to try to do this without the use of our graph. Okay. So reflection over the y equals x goes first. And all that does is flip-flop the coordinates. So A prime will still be at 2, 2. B prime, if you flip-flop the coordinates, will be at 0, 4. And C prime, if you flip the coordinates, will be at 2, 4. And that's what happens when you do a reflection over y equals x. All the coordinates do is flip or change positions. Okay. Now we're going to go ahead and do the reflection over the y-axis. Remember, in a composition, you always do the second transformation on the triangle you just got. And when you reflect in the y-axis, you change the x. Okay, so we're going to change the x to the opposite of what it was. It was 2, now it's -2, and we leave y the same. Okay. We can't change 0. There's no such thing as a -0, so that's just going to stay 0. Okay, 4. And then C double prime, if we change the x to reflect in the y, we end up with -2, 4. And there is our final coordinates. And that is our answer. They didn't say that we had to graph it, so we'll leave it as that. So just a little hint. Okay? Remember, when we do y equals x, the coordinates just switch positions. So the y coordinate comes first, the x coordinate comes second. And when we do a reflection in the y-axis, we change the x. Okay, so there's our rules that we were using to get our points. All right, so a quadrilateral is a polygon with 4 sides. Okay. Parts of a quadrilateral, there's what they call consecutive sides. Consecutive sides are sides that share a vertice. Okay. In our picture here, we have an example of consecutive sides. We're going to stick with AD when we talk about our sides. And so AD has 2 sides that are consecutive to it. We could say AD and AB. The vertice they share is A. Or we could stick with AD and go consecutive in the opposite direction and pick DC. D would be the vertice that they share. Okay, those are sides or line segments, so they get the bar over them. Okay, opposite sides would be sides that do not touch. They do not share a vertice, and so if we stay with AD, opposite side of AD would be BC. Notice they don't have any letters in common, so they're not sharing a vertice. Those would be opposite sides. Okay. Consecutive angles. So when we talk about angles, let's stick with angle D here. Okay. When we talk about consecutive angles, those are angles that are, they say next to each other. However, when we use the word next to, we usually think of adjacent. This isn't such the same thing as adjacent. In our quadrilateral, if we have angle D as the angle we're talking about, consecutive angle would be angle A. Or if we stick with angle D, we go consecutive in the other direction, we would end up with angle C being our consecutive angle. Okay, so consecutive angles. Angles kind of go in order, all right, that are next to each other. Opposite angles are angles that are not next to each other. We'll stick with angle D, and when we talk about opposite angles, we would go with angle B being the opposite angle to cross from it. Okay. We have diagonals. These are line segments whose endpoints are opposite vertices. So for instance, if we take D and we connect it to the opposite vertice, which is B, DB would be one of our diagonals, or BD. Okay? If we take A and we connect it to its opposite vertice, which would be C, we get diagonal AC or CA, it doesn't matter. Okay? In this picture, we don't have any altitudes, but I could draw an altitude in. Okay? Altitude, remember, is another word for height. And if we go from point A and we go perpendicular to the opposite side, okay, and let's say we put an E here. So then we could say AE would be a good altitude or height. Okay. It's a line segment extending from a vertex perpendicular to the line containing the opposite side. And remember, perpendicular lines form right angles. Okay. All right, down below is our quadrilateral family tree here. It's very important that you know our tree. Some quadrilaterals have special names and properties, which we'll spend a day on each. These quadrilaterals have more properties than others. Okay, the hierarchy lists the quadrilaterals that have the least amount of properties at the top, and the quadrilaterals with the most amount of properties at the bottom. All right, so for instance, quadrilateral really just has 4 sides. There's nothing special about its sides. Okay, it just has 4 of them that connect. Whereas a trapezoid has at least 1 pair of parallel sides. Okay. When we get to the isosceles trapezoid, it also has at least 1 pair of parallel sides, which makes them a trapezoid. And there's a few properties that it has, but one of them could be that the diagonals are congruent, whereas in the trapezoid, they didn't have to be. So he gains a property, they change their name. Okay, so this is the isosceles trapezoid. He has a few other things too. Okay, like these 2 sides are called the non-parallel ones. They're congruent. Okay, they have base angles down here equal, base angles up here equal. We'll talk about them when we get to parallelogram and trapezoid and each one. Okay, parallelograms over here, he has 2 pairs of parallel sides. So because he still has 1, that's why he's hooked up to a trapezoid. So a trapezoid has at least 1 pair, but if he has 2, now he becomes a parallelogram. Okay. A parallelogram can turn into a rectangle if it has what it has above it, but also another property like right angles. Okay. A rhombus is like a parallelogram because it has 2 pairs of parallel, but it also has 4 congruent sides, whereas the parallelogram doesn't have to have 4 congruent sides. Okay. And then if you take the properties that come from this side, like the 4 congruent sides, and the properties from this side with the 4 right angles, you end up with a square. And he has the most amount of properties. He has all the properties of all the shapes up above him. So it's a little bit complicated, but hopefully we'll learn as we go. Okay, all right, I'll see you guys on the next side, next page of notes.